Very good afternoon, everyone. My name is Sumit Kumar. This is the week 8 of Soil Mechanics Geotechnical Engineering 1 coursework. And today we are going to study the consolidations and many more things like that. Before starting, first of all, starting with my introduction, my name is Sumit Kumar. I am PhD research scholar at IIT Dhanbad. This course is taught by Professor Dilip Kumar Avaith from IIT Kharagpur, and I am very much sure that this course will be helpful for all of you in one way or the other in understanding the concepts regarding the subjects. Additionally, some point I want to mention before going ahead that this lecture is going to take place for 2 hours, and in mid between, if due to some network issue, if connection goes down or any problem, I get disconnected, please be remain in the meeting. I will rejoin and start from there only. Apart from that, I am recording this video for you, and it will be shared with you by the NPTEL team through the YouTube links. And the content which we are discussing over here and some additional content, if I think it would be required for the better understanding of the subject, I will share it with you on the Google Drive. The link will be already with you, and those content will be uploaded in that link only. Hence, that much instruction. And this course is going to take place for 12 weeks. It is the 8th week, so 4 more class after this. So I am very much sure that this coursework will be very much helpful for all of you in developing the understanding of the subject, that is the soil mechanics. Okay, so without delaying too much, now we can start. So some additional point I want to mention you over here for the people who are watching this video on the YouTube, that please try to solve the problems, specifically the problem which we are discussing in the class. And apart from that, some problems which you pick out from any of the standard geotechnical books, that will be very much helpful in developing the understanding of the concept. Because in general, in our curriculum also we discuss about the theoretical concepts, but their numerical application is very much important. Basically, when we say now that theoretical concept is the knowledge which we gain, but when we apply it in the field or apply it in the labs, we get develop the better understanding. So afterwards, when you once graduated, if you are the BTech students or the final year students, you see that the practical application will be comes out from that knowledge only. But if you have the practical understanding, specifically the thing which you are discussing, like we have discussed the shear strength, the test like the box test, triaxial test, vane shear test, so those things if you have performed. And additionally, I have also mentioned in the previous class that however, due to some technical facility, some instrument may be out of order at your institute, so not to worry, you can go and look out those tests specifically on the NCTEL. The NCTEL is a YouTube channel over there. The practical implementation of the test, how the instruments are operated, what are the pros and cons, everything are there. So I will suggest you to go over there and look into that. That will be very much helpful for all of you. So without further delay, now we are coming to the today concepts, that is the shear strength. Basically, if you remember, we have discussed the shear strength very in the previous class. We have started the shear strength very mild concept. In the previous class, we have discussed everything about the test and many more things. We have solved the problem associated with the shear strength. Over here, we briefly discuss the shear strength and move ahead to the consolidations and their problems. I specifically focus on the problem because the theoretical concept you must have understood with the concepts or the video which are already there with the in the YouTube of the sir only. If you have gone across that thing, I think so the theoretical concept is more or less clear. But I mostly focus on the problems or the types of problems, types of multiple choice question which could be framed from this subject will be the point of concern in my opinion. So over here, we first of all briefly discuss the shear stress, some of the concepts through which we calculate the normal stress, shear stress, and some principal stress, principal strain concept. We also briefly summarize the Mohr circle concept, we summarize how we calculate the radius. We also comes to know that basically the principal there are the two principal stresses, maximum and minimum, that we also come across. As if you remember in the previous class, we have discussed about the approach through which the stress is applied on the soil. Specifically when we are discussing the triaxial test over there, I have firmly explain you with the help of schematic diagram, in which I have shown that there is a soil surface is there, and below the soil surface at certain depth there are some stresses applied in the horizontal direction. So the two direction in the two stresses in the two direction are more or less similar, but in the third direction is different. And how that things happen, that is the main point of concern, main point of discussion which we have came across in the previous classes. So up to this, I think so there will be no doubt in anyone mind. So I think so we can move ahead. That what we are going to discuss in this class is very much clear. And ultimately, I have framed approximately 30 question, 25 to 30 question, 20 question in the multiple choice question, and some 15 question in the numerical problems sections, to briefly explain the things which are most important for this subject, right? So starting with the summary which we are talking about for the shear strength. The shear strength of the soil may be attributed by the three basic components. It is when we have started the shear strength concept, we started from here only, in which we see it as the frictional resistance to the sliding between the solid particles, cohesion and the adhesion between the soil particles, interlocking and the bridging of the solid particle to restrict deformation. These are the main things through which the shear strength of the soil is provided, through which the soil attain a specific strength which is said to be shear strength. Now you can see over here that two parameters are there. One is the normal stress and second is the shear stress. So normal stress comes as the sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta minus 2xy sin 2 theta. And this thing is very much aware if you have read the strength of material over there also, when we talk about the stresses in the x and y direction, and from that we calculate the normal stresses, we calculated the shear stresses. So similarly the shear stresses comes out to be sigma x minus sigma y by 2 into sin 2 theta plus tau xy cos 2 theta. Over here what we want to say, we want to say at a certain plane as shown over here, if some stresses is applied in the two perpendicular direction is known, we can calculate the stress in certain other direction which is normal to both of them, that is said as sigma n, and the angle between those two is given as tan 2 theta equal to minus tau xy by sigma x minus sigma y by 2, as presented from the figure given in the figure C. Right. Now, moving ahead, taking this concept forward, then we have written that the sigma n minus sigma x plus sigma y by 2 plus tau n square equal to sigma x minus sigma y by 2 tau xy square. Basically what they want to say, when we have calculated the sigma n as equal to sigma x plus sigma y by 2 cos 2 theta plus sigma y sigma x minus sigma y by 2 sin 2 theta, basically whatever thing written over there, cos 2 theta minus 2 tau xy sin 2 theta, we have calculated the sigma n and tau n, and when we relate it the sigma x and sigma y in this form also, these two value comes out to be equal, and hence the expression is the equation of circle with the center at sigma x plus sigma y by 2 and 0. Basically on the x-axis the intercept is sigma x plus sigma y by 2, and on the y-axis it is 0. Hence the origin lie on the x-axis of the Mohr circle, and the radius of that is nothing but sigma x plus sigma y by 2 square plus tau xy square. Right. Now you can visualize it on the this figure as well. As you can see from this figure that the presentation has been clearly visible, that the how the shear strength act on the plane. So you can see that the positive angle of circle are obtained when measured in the counterclockwise sense, while the negative on the circle are obtained in the clockwise sense. An angle of 2 theta on the circle correspond to the angle theta on the element, right? This thing is very much important. When we draw in the 2D plane, basically in the xy plane, over there if the angle is presented theta, that angle on the Mohr circle is 2 times of theta basically, and this thing we have discussed over here in the image. If it is shown as 2 theta, it is theta on the xy plane. Now talking about the principal plane and the principal stresses, we have talked about some points like in the starting only. I have said that we are going to discuss about the maximum principal stress and the minimum principal stress. Over there, first of all we need to understand the principal stress, but before that we need to develop the understanding about the principal plane. So principal plane is a plane that is acted upon by the normal stress only. It is known as the principal plane. There is the no tangential or shear stress present. Now talking about the principal stresses, the normal stress acting on the principal plane is referred to as the principal stresses. At every point in a soil mass, the applied stress system and that exists, the principal planes corresponding to these principal stresses are called major and the major, intermediate and the minor principal planes, and are so named from the considerations of the principal stress that act upon them. The principal stress sigma is known as the major principal stress act on the major principal plane. Now, let me read this again for you to elaborate the things. Basically, this definition is already elaborated in itself, but for uh, another consideration, let me read. It say that the normal stress acting on a principal plane is referred as the principal stress. So first of all, we understood the what is the principal plane. The plane that is acted upon by the normal stress only is known as principal plane. There is the no tangential or the shear stress present. Hence, it is a plane in which only principal stress is there. So that condition is said to be the in which the principal plane is there. Now, when we are discussing about the principal stress, we say that the normal stress acting on the principal plane is referred as the principal stress, and at every point, sorry, at every point in a soil mass, applied stress system that exists can be resolved into the three principal stresses that are mutually orthogonal. The principal planes corresponding to these principal stresses are called major, intermediate, and minor principal stress, and are so named from the consideration of the principal stresses that act upon them. The principal stresses sigma is known as the major principal stress acting on the major principal plane. And subsequently, you can see over there that the major principal plane is presented and the minor principal plane is presented in this figure. The stress acting sigma 1, sigma 3 is also shown over there. The minor principal plane, the stress acting is presented is sigma 1, on the major it is sigma 3. You can see the same thing from the figure B, in which the sigma 1 is presented in the vertical direction on that plane, while the sigma 3 in the horizontal direction. So the major value is sigma 3. So the major principal plane, the stress value is presented sigma 3, and on the minor it is sigma 2. Now we have already discussed that the tau equal to sigma 1 minus sigma by 3 by 2 sine 2 theta. So sigma n equal to sigma 3 plus sigma 1 minus 3 cos square theta. So that is not the point of concern which we are discussing over here. This is just for symmetric presentation. We have discussed the relation to calculate the angle tan 2 theta equal to tau by sigma x minus sigma y by 2. Now we are going to discuss about over here. You can see the theta and 2 theta and phi is presented. So the relationship between the theta and phi from the figure, uh, angle DCO, if you see the point DC and okay, DCO basically the angle made at point C at DCO is 180 minus 2 theta. How? Basically, we know that the internal angle, overall angle at point C is 180, and the external angle is predicted as 2 theta. So the angle at point C is going to be 180 minus 2 theta. Now, in triangle ODC, the in triangle ODC, angle DOC become phi, which is predicted as phi, but ODC equal to 90 degree, OCT equal to 180 minus 2 theta. ODC is 90 degree, right? The 90-degree line is plotted over there. It is tangent to vertical line is 90-degree line. So 90 degree correctly. And OCT is 180 minus 2 theta. And these angles are summarized as 180 degree. How? Because the angle between the all the internal angle of the triangle comes out. Sum of the angle of triangles is come out to be 180 degree. So we can write phi plus 90 plus 180 minus 2 theta equal to 180. Over here we came across theta equal to 45 plus phi by 2, where phi is the angle of internal friction and theta is the angle of right. Now, when we move ahead, we know already the equation tau f equal to c plus sigma tan phi. Apparently, tau f equal to c dash plus sigma dash tan phi dash on talking about the effective parameter. Similarly, the sigma 1 minus sigma 3 is written as 2c cos phi plus sigma 1 plus sigma 3 sin phi, and sigma 1 dash minus sigma 3 dash is written as 2c cos phi dash plus sigma 1 dash minus sigma 3 dash sin phi dash. Now, over here you see the shear strength. In shear strength, we are going to determine the shear strength parameter. For that, we have discussed about the direct shear test, which is also called as the box test. Apart from the triaxial test is there, in which the UU unconfined unconsolidated test, CD test, consolidated drain test, and CU test, confined consolidated undrained test are there. Additionally, the unconfined compression test, UCS test is also there, where sigma 3 confining test, one stage is not there. And in the vane shear test, we provide a torque. In vane shear test also, it is applied from the both direction or from the one direction, depending upon that. The stress value become d by pi d square into h by 2 plus d by 6 or h by 2 plus d by 12. Now we will discuss briefly all of them one by one, so we can move ahead with the new thing. So over here, the shear strength, something is presented in which you can see the stress acting in the vertical direction is presented written as sigma 1 and sigma 3 in the first figure, which comes out to be the sum of the sigma 3 acting in the compressive direction all across the plane, which is the confining stage, in which the stress acting on the soil body is compressive from the all direction. In the actual triaxial test, we use fluid as water. We can use other fluid as well, but in general we use water. So it applies the stress from the all direction as same amount sigma 3 due to water. So that is the confining pressure. That in additionally we are applying the deviatoric stress, which come out to be sigma 1 minus sigma 3. When we sum them up, it comes out to be figure A, the first figure which is presented in the current slide. Now, as you see, we have discussed about the triaxial test in the previous class also, but over here when we are summarizing all the things very briefly, yeah, I already mentioned the UU test, CU test, and the CD test is there. Over here we discussed in the previous class as well that when we draw the Mohr circle and draw the tangent, the intercept which it made on the y-axis, that is the tau axis, is said to be cohesion, and the angle it makes with the horizontal plane or the horizontal line is said to be the angle of internal friction. Over here you can see that the Mohr circle are drawn, in which first of all sigma 3 is applied and then the deviating stress is increased. And basically if I describe this with the help of pointer, so later you can see that first of all we applied sigma 3 value, then we apply the deviating stress, that is sigma 1 minus sigma 3. On the basis of that we comes to know the sigma 1 value at which the failure takes place. Apparently in the second case we again apply the sigma 3, that is the confining stress, but that value got to be increased, and again we apply the deviating stress, and then we see the difference between the sigma 1 and sigma 3 comes out to be same, so failure takes place at this section. Similarly for the next case, the sigma 3 value is again increased relatively more as compared to the first and second considerations, and the result clearly shows that the stress and the radius of the Mohr circle which is drawn for all the three cases after increasing the value of confining pressures comes out to be same, and the tangent drawn at them given the value of cohesion, which is while the angle, if it makes some angle, the angle made with the horizontal is the angle of internal friction. Now when we move ahead we see that in the previous class we have elaborated it very effectively with the help of the very long discussion in which I have tabulated the result which is asked in the question. So the understanding of that I think it already with you. So I don't think so I need to elaborate, but I will discuss it briefly. Again, as I have discussed in the previous slide, in which I have mentioned that the stress acting in the as in the previous slide you can see we have discussed that the radius of Mohr circle comes out to be same, but over here first of all we apply a specific amount of stress sigma 3, that is the confining pressure. So on that the sigma 1 value comes out over which the failure takes place. Basically we increase the deviating stress and the at the stress at which the failure takes place is sigma d is calculated, then we know sigma d is sigma 1 minus sigma 3. Hence on the basis of that we calculate the value of sigma 1, and we draw the circle. Apparently in the second case again we change the value of sigma 3 to get the value of sigma 1, and when 2 to 3 or more than 3 circles gets drawn, we try to draw a common tangent passing through them, and the tangent make an angle with the horizontal axis that will give the angle of internal friction apparently. However, in the previous case slides which we are discussing, which the horizontal line is drawn because the radius is similar, but over here the radius of all the circle by increasing the confining stress in the effective stress and total stress approach comes out to be different, and the common tangent drawn from all of them is also make some different angles, so that might be accepted that we could easily evaluate the things which have needed in this section. Now over here the CO test result is discussed. Now in the compression test, that is nothing but UCS unconfined compression test, UCS by 2 equal to C. Basically over there we directly calculate cohesion. So unconfined UCS is the cohesion, or UCS equal to 2C. In that manner we say where C is the cohesion or the angle of or the cohesion basically for the clays one. Now when we talk about the stress strain relationship can be obtained from the result of the triaxial test or the direct shear test. So in the direct shear test the results are plotted in the form of shear displacement, that is the shear displacement on the x-axis versus the shear stresses on the y-axis. However, in this figure presented over here, you can see that the shear stress is presented in the y-axis in one way or the other, because sigma 1 minus sigma 3 by 2 is that only, while on the horizontal axis axial strain is present, and the graph show the undisturbed sensitive clay, remolded sensitive clay, and the intensible clay. So, in the triaxial test, the deviator stress is plotted as the ordinate against the axial strain in percent. The unconfined compressor test data are shown by plotting the axial stress against the axial strain. So you can see the angle is also presented here, and the figure is drawn for the undisturbed sensitive and the remolded intensive glaze. Now, when we go ahead, which we have discussed about the volume changes, in which we have talked about the over consolidated, normally consolidated, additionally loose and dense and soil condition is also evaluated on the basis of that, in which we have said that the over consolidated place shows the greater strength than a normally consolidated clay and has a pronounced peak which occurs quite early. The stress force of as the strain increases minus a phenomenon is called the work softening. Over here you can see that for the over consolidated clay, first of all the volume get reduced very little, and then the volume is going to be increased. Apparently for the normally consolidated, it show the progressive change in one direction only. Similarly for the over consolidated clay and the normal consolidated clay, the difference between the stress and the axial strain is also presented, in which we could say that the over-concentrated clay after this small interval decreases in volume, shows a volume increase upon the shear, while the normally concentrated clay gets the compressed when sheared. Now, uh, the same figure is presented, in which the deviating stress, the volume change, and the wide ratio is presented. In the wide ratio plot, the strain is on the shear strain is there on the x-axis, irrespective of the other two cases, in which the axial strain are there. Now, we are comes to one of the end statement, in which we are discussing the Wayne shear test. So in the Wayne shear test, we calculate tau equal to t by pi d square into h by 2 plus d by 6. This is same thing written in the another fashion. So t equal to pi cu into d square h by 2 plus d cube by 6 for the shear both at the top and bottom, while for it's from the both the side t by pi 2 one side h by 2 plus d by 6 is not d by 12. So this comes out to be shearing at the bottom only. That's why it's become 1 by 2 times. So d cube by 12. Now, before moving to the consolidation, let me take up some problem related to the things which we have discussed it. But before that, I need a small break of 2 minutes. So let's take a break of 2 minutes, then we will start again. Okay, sorry for inconvenience. There are some issue related to power and many more things. So it may be possible that I need to take one more break before finishing up, before reaching to finalizing the class. So that is the situation like that for today only. So please consider it. Okay, so we are talking about compressibility of soil. So what is the compressibility? So before that, we need to understand the terms like the consolidation. So starting with the introduction for the consolidation, the effect occur for the saturated fine grained soil, is the effect which we call consolidation. What are the things associated with this? So a large wheel load rolling along roadway resist on the clay will cause an immediate settlement, which is recoverable once the wheel falls. If the same load is applied permanently, there will be additional consolidation settlement. Yes. Now let me break you for one by one. So over here, example is said that a large wheel load rolling on a roadway resting on the clay will cause the intermediate settlement which is recoverable on the wheel pass. So let me break in the other way, that suppose at a specific place you kept a bag which is filled with heavily filled trolley bag which has too much weight. Suppose at some locations, and over there above the road is not the rigid pavement, it is a flexible pavement. Over there if you kept, and it is not talking about the flexible or rigid pavement, it is the road which is sustained on a soil road only. So over there some imprint get developed, but over the time, if we kept it a heavy load over there, it will sustain up to some extent. But when we remove the load, so in a similar fashion, suppose a bullock cart or maybe a tractor or maybe a vehicle like trucks is travel from one place to other at certain location where the recoverable strength is there with the soil. Hence, once the load applied, it gets sustained a specific settlement, but afterwards it will recover apparently in no time once the load is removed. Up to a certain extent might be not completely, but up to a certain extent that might get recovered from their earlier positions. Now, if the same load is applied permanently there, suppose we have kept the same amount of load which is passing from that section at that section only for infinite duration of time, or maybe we have constructed some structures like that that will sustain there throughout their lifetime. Hence the settlement takes place at that place is different because the stress applied on those specific sections is there for a longer duration. Now, we talk about some more point in the consolidation, like the consolidation test and how the consolidation takes place. Typically, we also discuss this parameter in terms of the clay soil and the sandy soil. We come to know that in the clay soil, the consolidation settlement is more and it takes place maybe 10 or 100 of years to complete, or more, even more than that. But in the sandy soil, the settlement takes place uh, um, is relatively less, but in a small duration of time, if we see it, it is quite large. So we will compare those things as well, and we will discuss the typical test result which we obtain for from the consolidation test for the two specific parameter for the soil cases. So let's move ahead one by one. In that, over here you can see the relationship is presented between the E and P, where E is the void ratio which is plotted on the y axis and P is the pressure which is applied over there. Similarly, the effect of expansion is presented. So first of all, once the loading is done, it is observed that the void ratio get decreased. But when the load is removed, it expansion takes place, and afterwards the again load is applied, the recompressor takes place, and when load is removed, it's not follow the same path through which between the void ratio and the pressure applied. It doesn't follow the same path, it follows the relatively different path, and on that basis only we plotted the EP relationship in which the y-axis void ratio is presented, and how when the load is removed and again load is applied and again removed, how the stress follow their path, how the regain of strength takes place is presented with this image. When we discuss it differently, we come to understand about the coefficient of volume compressibility, which is related to the volume change, in which we say that the volume change per unit of the original volume constitutes the volumetric change. If a mass of soil of volume V1 is compressed to the another volume V2, the assumption is made that the change in the volume is caused by the reduction in volume of voids. Basically, we say that the solid is not compressible. It only compresses because the removal of the excess pore water pressure present over there, because the initial settlement takes place immediately once the load is applied. The air over there is removed immediately, so the water which is present in those voids get removed, and apparently the consolidation takes place. From there, this assumption is made that the mass of soil of volume V1 compared to volume Q2. So the assumption is very much clear that the change in volume caused uh, by the reduction in the volume of voids at that specific locations. Talking about the volumetric change, the expression could be written as V1 minus V2 by V1, where V1 is the initial volume, V2 is the final volume which is achieved due to the consolidations. And when we relate it with the void ratio, it comes out to be E1 minus E2 by 1 plus E1, where E1 is the initial void ratio and E2 is the void ratio and after the compression. And apparently the E1 is the void ratio at pressure P1 and E2 is the void ratio at pressure P2. When we relate it in the other term, we comes to know about the volumetric change or the volume compressibility term MB. So volumetric change is written as V1 minus V2 by V1, which could also be written as H1 minus H2 by H1, because the change in volume is nothing but height, change in height into area of cross section. If we suppose H1 into A minus H2 into A divided by H1 into A, area get is removed from all the above and downward expressions, because area is assumed to be constant, and we could assume it in the soil of case. So the term could also be volumetric change, it could also be written as delta H by H. Over here, when we rewrite the expression, we could write as E1 minus E2 by 1 plus E1, and E1 minus E2 by E1 minus E2 we write differently as the change in pressure. And when we apparently write it, we say MB equal to AB by 1 plus E naught E1, where MB equal to where AB equal to delta E by delta sigma, change in pore water, change in void ratio by change in pressure. So MB equal to AB by 1 plus E1, where AB equal to delta E by delta P, right? Now, moving ahead, we see that for most of the practical engineering problems, MV values can be calculated for the pressure increment of 100 kilonewton per meter square in excess of the present overburden pressure at the same depth. Once the coefficient of volume decreases has been obtained, we know the compression's unit thickness, unit pressure increase J. It is therefore an easy matter to predict the total consolidation settlement of the clay layer of the thickness H. And the total settlement could be found and rewritten as PC equal to MB into DP into H. Now, you see over there here some typical value is mentioned for the different soil in which the MB value lie in the range of 10 to 2 meter square plus mega per mega Newton. While for the plastic clay, this range change to 2 to 0.25. However, for the hard clay, this lie in the range of, or maybe for hard to stiff clay, lie in the range of 0.125 to 0.25 meter square plus mega per mega Newton. Now, over here, some example is mentioned in the tabulated format. So, before moving with this, let's take a small break of 2 minutes. I need to switch to the another system and due to some network problems. So, we will again start in 2 minutes. Okay, welcome back. So we will move ahead. What we are discussing. Okay, so we are talking about the problem associated with the consolidations, and we have discussed about the volume of compressibility. So coefficient of consolidation and other things also comes in picture one by one, and we will see the problem which get developed with the same concepts in the coming slides. Okay, so first of all, over here you can see in the table it is presented result obtained from the consolidation test on a sample of the saturated clay. Each pressure increment have been maintained for 24 hours. After it had expanded for 24 hours, the samples was removed from the apparatus and found to have the moisture content of 25%. The practical specific gravity of the soil for this test is taken as 2.65, and over here it said that the plot the void ratio to the effective pressure of the curve and determine the value of the coefficient of volume change for the pressure range between 250 to 350 kilonewton per meter square. Now you see that the pressure is mentioned in kilonewton per meter square, and the thickness of sample is also mentioned in mm, and how it changes when it increase the pressure from 0 to 50, it changes from 20 to 19.65, and subsequently when it get increases up to 800, its value is what changed to 18.95. But once the pressure get removed, it again comes out to its earlier shape up to the 19.25 mm. Now the solution over here it is mentioned that the W is 0.25, G 2.65. So S E equal to WG. From there we could calculate the value. We consider S as 1, we calculate E as 0.662, and this void ratio corresponding to the sample thickness of 19.25, which comes at the end when the pressure is 0. So we know the relation earlier in the previous slide only, where dH by H equal to dE by 1 plus E naught, where uh, we have written the formula in that term as V2 minus V1 by V1 equal to H2 minus H1 by H1 equal to dE by 1 plus E1, or E2 minus E1 minus E2 by 1 plus E1. So from there we calculate the value as dE equal to 1 plus E1 by H1 when we change it from this side to that side. So E1 is known to us as 0.662. So 1.662 by 19.25 into DH is DE, hence DE is 0.0865 DH. When we write in this term, that is a change in the H, change in DH is related to the change in void ratio. Now, again, some pressure H and DH value is presented. Subsequently, DE value is also presented for the same parameter on the basis of this equation, because D is known to us, DH is known to us, so E is known to us, and subsequently the plot between the void ratio on the y-axis and the pressure on the x-axis is also plotted in that is the asked in the question, and hence it is mentioned that between 250 and 350 we need to calculate the value of AB, that is delta E by delta sigma. So we have calculated that, that comes out to be 0.008 kilometer per meter square, and we know MV equal to AV by 1 plus E naught. So once the AB is calculated, AV by 1 plus E naught is calculated, which comes out to 4.8 into 10 to the power minus 5 meter square per kilo Newton. Now, similarly, the next problem is also mentioned in the similar order, and the same type of calculation have been made for the basically 250 to 350 over here also asked. So the calculation has been made and the plot is drawn. So I leave this for all of you to look by yourself, because one question I have discussed. So we could move to the next concepts, which comes over here as the compressibility of soil, which we are going to study. How in the practical work, how in the practice work we summarize those things. So the practice of working back from the end to the end of the consolidation stage, that is from the expanded thickness in order to obtain the EP curve, that is the void ratio and the pressure curve, is generally accepted as being the most satisfactory, as there is a little doubt that the sample is more likely to fully saturated after the expansion than at the start of the test. So it is however possible to obtain the EP curve by working from original thickness. The void ratio is given by E equal to volume of void by volume of solid. Volume of void is nothing but total volume minus volume of solid, and when we convert it term of h, we remove the a value from all of them. It becomes h minus hs, height of solid, divided by height of solid. So h minus hs by hs, that is nothing but delta h by hs, where a is the area of cross section, which is assumed to be constant and removed from the numerator as well as denominator. And in the term of thickness, we have calculated hs as ms by rho w into gs into a, and we know that this is the value. And over here we make the sense to calculate the void ratio. So additional information for this problem is like that the sample diameter is 75 mm, thickness is 20 mm, and mass of sample after the removing from the consolidation apparatus at the end of test after drying is 135.6 gram. So from this we have calculated the value of HSI 11.58 mm. So that is not the things which I have keen to discussion over here, because these discussions are there in the videos itself. So now I quickly move to the next concept so that we could move to the final thing which we want to achieve from this class. So first of all, we discuss about the compressibility of the soil. So starting about this, we say that a clay is generally formed by the process of sedimentation from the liquid, in which the soil particles were gradually deposited and compressed as more materials was placed above them. The EP curve corresponding to the natural process of the consolidation is known as a virgin consolidations curve, and the curve is approximately logarithmic. If the values are plotted on the semi-log scale, the results are the straight line, and the equation is E equal to E naught minus CC into log P naught plus delta P by P naught. So we also represent this value as coefficient of compressibility, Cc equal to delta E by log P2 by log P1. Once we move ahead, we see that the coefficient of compressibility or coefficient of compression or coefficient of recompressibility, or sorry, coefficient of compression and coefficient of recompression are the two terms which we relate those terms in the term of the logarithmic term while plotting on the semi-log plot, and it comes out to be straight line. So we will see some questions are also there related to same. So over here you can see that actual curve look like so in the first part of the figure, but when we plot on the log p graph or the semi-log graph, it comes out to be straight line, and from that we could calculate the coefficient of compression, which is given as delta E by log P2 by P1, or you can say E1 minus E2 by log P2 by P1. Okay, so the compression curve for a normally consolidated clay is one that has never experienced the consolidation pressure greater than that corresponding to its present overburden. The compression curve in such a soil is shown in the figure. So as I have discussed earlier in the previous class, the term normally consolidated and over consolidated. Another term is also there, that is the over consolidation ratio, in which we say that the stress applied in the past to the stress applied in the present. So if the over consolidation ratio is greater than 1, it is said that the stress applied at the specific site or at the concerned site which is taken under discussion in the past is more than what it is applied in the present time. So the over consolidation ratio is greater than 1. In a similar fashion, when it has been said that the consolidation settlement takes place at a specific sites, it's look like differently for the normally consolidated and the over consolidated clay when it is plotted. So you see that the normally consolidated condition, the stress applied at that position is the extra stress applied at that location due to the superstructure weight or anything is for the first time only. So when we talk about the clay was originally compressed by the weight of the material above along the virgin consolidation curve to the some point A. Owing to the removal of the pressure during the sampling, the soil has expanded to point B. Hence, from B to A, soil is being recompressed, whereas from A to C, the virgin consolidation takes place, curve is followed. The semi-log plot corresponding to this is um, um, shown over here as you see from this graph. Let me read first of all things, then comes over there. So and over for talking about over consolidated clay, and over consolidated clay is one which has subjected to pre-consolidation pressure in excess of the existing overburden, the resulting compression being much less than for the normally consolidated clay. Hence the semi-log plot is no longer a straight line, and a compression index value for an overconcentrated clay is not constant all across. Hence, it become very much important that for the overconcentrated clay, the CC value, compression index value is not constant all over. For the EP curve, it is possible to determine the approximate value for the pre-consolidation pressure with the use of graphical method proposed by Casgrande. First estimate the point of the greatest curvature, then draw the horizontal line through AB and tangent to the curve at uh, AC and bisect the angle. We are discussing about this figure only. So I could not show at this point of time side by side, but let me leave it there in the PDF. Once you are revising those concepts, you keep the picture side by side and you could understand the point of discussion. And that is not very difficult thing. That is also come across you when the sir is discussing these concepts in the class. So ultimately, we come to know that CC value is calculated as delta E by log sigma P2 by P1, and this CC value is used to calculate the settlement due to consolidation, and that ultimate relations comes out as consolidation, primary consolidation settlement as CC into H, where H is the depth of set clay layer, which is going to be settled due to the consolidation. So Cc into H by 1 plus E1, where E1 is the initial void ratio, into log P2 by P1, where P2 is the pressure applied at the end and P1 is the initial pressure. When now we are moving to use these equations in one way or the other to calculate the problems associated with the same. Let's see that what thing we are going to discuss from here. So first of all, before moving to that, we see some empirical relation in which water content or the liquid limit could be used sorry, to calculate the compression index. So the what some approximate relation is over here, in which the Tarjali and the PEC 1948 have shown there is an approximate relationship between the liquid limit of the normally constituted soil and its the compression index. This relationship has been established experimentally and is given as CC equal to 0.009 WL minus 10. Now let's move ahead to a problem associated with the concept which we have read, the consolidation settlement concepts is here, over here. So first question say that a soft normally consolidated clay layer is 15-meter thick with a natural moisture content of 45%. The clay has saturated unit weight of 17.2 kilonewton per meter cube. A particle of specific gravity 2.68 and the liquid limit of 65%. A foundation will subject the middle of the clay layer to a vertical stress increase of 10 kilonewton per meter square. So delta P is given. Determine the approximate value of the consolidation settlement of the foundation if the groundwater table is at the ground level only. So for this problem we have to solve. So I have already solved this problem in the next 2-3 slides, and the given term is also mentioned over here. So let's see. So first of all, it is given that the thickness of the settlement layer is 15 meter. The moisture content is comes out to be 45%. So the gamma sat is already given as 17.2 kilonewton per meter cube. GSE 2.68, liquid limit is 65%. Stress increase, that is delta sigma or delta P, is 10 kilonewton per meter square, that is 10 kPa. And the groundwater table is at the ground level, so it is fully saturated conditions, and gamma W is 9.81 kilonewton per meter cube, which we are going to use in this problem. So soil is fully saturated and normally consolidated. These things is mentioned or we have assumed. Now when we talk about the one dimensional consolidations, so we use the relation to calculate the CC at 0.00 WL minus liquid limit minus 10, and that is WL minus 10. Also the applied stress increment in is represented as 10 kPa acting on the mid depth used directly in the consolidation formula. And so over here, first of all, we calculate the CC value as 0.009 into liquid limit minus 10 equal to 0.009 into 65 minus 10, that comes out to 0.495. Now we calculate the gamma sat value as GS into E, GS plus E by 1 plus E into gamma W. And solve for E, we have calculated the E naught value because we already know the gamma sat, and only unknown value is gamma saturated because gamma W is taken as 9.81, which is the standard value. From here, when we calculate the E naught value, now the initial effective stress at the midpoint of the settlement consolidations layer is calculated at Z is equal to 7.5 meter as effective unit weight as gamma dash equal to gamma sat minus gamma W, that it comes out to be 7.39 kilonewton per meter cube. When we calculate the effective stress at that depth, it comes out to be 55.45. So our relation comes out to be CC into H, that is the settlement layer, that is 15 meters. So CC is 0.495 into H in 15 divided by 1 plus E naught, that is 1.230 by 1 plus 1.230 into log sigma naught plus delta sigma by sigma naught. So the sigma naught value is 55.425. So 55.425 plus 10 is in the numerator and 55.425 in the denominator. When we solve this, delta H comes down to be 239.0.239.8 meter, that is nothing but 240 mm approximately. So the 240 mm or 240 mm of settlement takes place in that 15 meter layer due to consolidation. So that much the thing which we are very keen to understand. Let now move to the some problem before moving to those concepts. So again, it is written for the over consolidated soil, some relation gets changed because in the over consolidated soil, some recompression ratio is also there, that is mentioned as CR. So the relation for calculating the settlement gets changed from CC to CR, and remaining all things are remain constant. A problem associated in which the compression index and recompression index both could be used is also there, but in this class I haven't taken that problem. In the next class I will try to show you, or maybe in the PDF which I am going to share as a course content for this class will also contain those things. Let's see what best possible things I will try to merge them, right? Now the relation relating the decompression and compression both is presented over here, in which CR into H by 1 plus into log sigma naught plus sigma PC, basically pre-consolidation stress applied at the pre-consolidation stage, minus sigma naught by sigma naught is there when we calculate the settlement due to recompression ratio. And for the compression, as we have discussed later, the same equation could be used. From here we are able to calculate the settlement. So with this we come up to some of the sessions for the theoretical concept. Now let's move to some problems are there which I have kept for a small discussions. So let's cover them all, and with that we will close the today lecture. So first of all, starting with small multiple choice question based on the shear strength, because if you remember, we have started the class with the shear strength, in which we have discussed about the various types of tests, considering the triaxial test, directional test, vein shear test, and the UCS test. So the problem covering those things are coming up. Let's see that. Afterwards, some numerical problem is has been kept to elaborate the thing which we have discussed earlier. Subsequently, we come to it and close our session for the day. Now, first of all, you see the question one say that the shear strength of soil is primarily due to cohesion, only friction, cohesion, and interlocking or water pressure. So again, some tricky point. Specifically in the numerical problem, if anywhere it irritates only, if you doesn't know the answer also, then you not mark that problem. Basically, only if in any question if you written only cohesion, only friction, then maximum chance that that is not the answer. But over here we have already, in the very second slide of the day, we have discussed these things, in which we have mentioned that the friction, cohesion, and interlocking are the three of the primary factor which is responsible for the shear strength in soil. So option C is the correct answer. Now, and then we have talked about the principal plane, if you remember. So the question related to principal plane is there. Subsequently, we have discussed principal stress. So the principal plane in a soil is defined as a plane with the maximum shear stress. No, plane with only normal stress, no shear stress. Let's see. Plane parallel to ground surface, plane with the pore water pressure only. So if you remember, we have discussed that the plane with the only normal stress and the no shear stress is the principal plane. We have in the definition we have discussed some other point as well. So on those point also the question related to principal plane could be framed. Now afterwards I have already said that the principal plane and principal stress, those points we have discussed. So the question related to same is mentioned over here, in which it is asked that the angle between the major principal plane and the plane of the maximum shear stress is 45 degree. In the figure in which the principal stress we have discussed, in the same plane, the in the bottommost right corner the figure is presented, in which the angle is highlighted. So the option C is correct for this given problem. Now moving for the next point of discussion, in which it is asked that for a purely cohesive soil, that is clay, under undrained condition, the angle of internal friction. I have already said many a time, it is if it is a purely cohesive soil, then it's the pure cohesive soil, so the angle of internal friction going to be 0, because when we draw the Mohr circle, which during the triaxial test we apply some sigma 3 value, we get some sigma 1 value at the failure, then again we increase the sigma 3 value confining pressure, then we again some other value of sigma 1, but the radius of all the circles comes out to be same. Hence when we draw the tangent to those Mohr circle, it comes to be horizontal line with the x-axis. So the angle with the vertical angle with the horizontal axis is 0. So angle of internal friction is 0 in all the purely clay, purely cohesive soil. All right. Now, so option C is the correct answer. 0. Now, over here, I am reading the question, I am giving the explanation, then showing you answer, just for the better understanding. So next question say, oh sorry, the answer comes out over here due to my mistake. So over here, the question is mentioned that which test directly provides under undrained shear strength CU of a clay. So you have already seen the answer. So that is the vein shear test. Right. Now, the next question is in the unconfined compression test, UCS test, the undrained shear strength is given by, so I have already said many a time UCS by 2 equal to cohesion. So, option number C. Oh, sorry. In the unconfined compression test, undrained shear strength is given as Cu equal to sigma 3. So I think so some problem in that question. I will check once and then let you know. Some other part of the problem is missing. So let's leave that and move ahead with the next problem in which it is asked the shear strength of sand is governed mainly by cohesion, internal friction, pore pressure, volume compressibility. So this is again a problem in which it is mentioned the internal friction. Why? Because in a sand cohesion is negligible. In a clay, angle of internal friction is negligible. So in the sandy soil, the shear strength is governed by its friction angle only, while in the clay soil, the shear strength is governed by cohesion, and those things you need to understand, and this type of basic and small problem come across you many a times. Now, you see, in the next question, it is asked that which type of triaxial test permit full dissipation of the pore water pressure. So first of all, starting with the UU test. In UU test, the in during the confining stage as well as in the deviating stage, the pore water pressure is not allowed to remove. So this is not the potential answer for this problem. So the next thing is asked that next thing is asked that whether CO test could be. So in the consolidated undrained test during the confining stage, the water is not allowed to pass. Allowed to pass out, but in the second stage, that is deviating stage, the water is allowed to dissipate. So this is also not the potential answer for this problem. So what could be the answer? Next is CD test. That is consolidated drain test. In the first as well as in the second stage, the water is allowed to dissipate, hence the full dissipation of pore pressure could take place. So option C is the correct answer, that is the CD test. Now move to the next problem in which it is asked that the stress strain behavior of the over concentrated clay shows no peak stress, pronounced peak followed by the strain softening, or elastic perfectly plastic behavior, or zero volume changes. So answer for this question is pronounced peak followed by the strain softening. Now, moving to the next problem in which it is asked that in the direct shear test, the shear stress is plotted against, okay, in a direct shear test, the shear stress is plotted against axial strain, shear displacement, wide ratio, effective stress. So answer is already mentioned in the question itself. So that is the shear displacement. So option B is the correct answer. And now we have talked about the question MCQ question related to the shear strength. Now we move to the compressibility and the consolidation. On those topics, some multiple choice questions are framed over here. Let's see that how much question you have understood with the concept which we have discussed today and the problem which we have come across in this lecture. So first question is the consolidation occur mainly in the sand, gravel, saturated clay, or the rock. So if you remember that consolidation settlement we have calculated mostly in the clay, saturated clay is the correct answer for this, because in the sand and gravel consolidation settlement takes place, but during the construction time well itself, and post that basically the water is allowed to flow out from those sections is very easy. So that's why over there the concentration takes place in that section only. So the option C is the most appropriate answer for this question, that is the saturated clay. Now next question is the coefficient of volume compressibility MB defined as, if you remember, MB equal to AB by 1 plus E naught. Okay, so Over here, the option is given in the different term. AV by 1 plus E naught. So let remain it there. I will give the description for this problem once we share the presentation with PDF with. Next is the compression index CC of the normally consolidated clay is approximately related to the liquid limit as 0.009 into liquid limit minus 10. So over here, anyone is confused between the option A and C, but this is liquid limit minus 10 and liquid limit plus 10 is mentioned over there. So these B remain concise and option A is the correct answer for this problem. Right? Now, next to the move to the next question, in which it is asked that a soil sample that has never been subjected to the pressure greater than its present overburden is called. If you remember, we have discussed this concept in the earlier classes as well. In today's class also, I have explained the normal consolidated, over consolidated, under consolidated. I haven't described, but over consolidation ratio I have discussed. So for this question, the option number A is going to be correct answer, that in the normally consolidated soil, a soil sample have never subjected to the pressure greater than its present overburden at that section. Now, when we talk about the next part of the problem question, it says the pre-consolidation pressure is determined using direct shear test, triaxial test, cascade method, or the audiometer dial reading. So if you have given the attention in the class, the cascade method is mentioned, that the pre-consolidation pressure is calculated with this mechanism. Now you can see the next question, in which it is asked that the degree of consolidation U is defined as the ratio of initial void ratio to the final void ratio, settlement at time 2t by final settlement, void ratio changes per unit pressure, or the effective stress, or the total stress. So degree of consolidation U is defined as the settlement at time to the final settlement, that is the degree of consolidation. Next question is about the according to Tarjali theory, the one-dimensional consolidation uh, drainage is assumed in all direction, vertical only, horizontal only, or the radial only. As I recall, the option number B is going to be the correct answer, that is the vertical direction only. Over there, we also come across some other equations like TV equal to CV into D by D square, the consolidated settlement, and delta U by U equal to delta H by H. We will see. Those things are also there in this presentation only. If time permits, we will discuss. Otherwise, I hope that if you have covered the class videos of the sir, you already come across those things. So main focus is over here in this class to explain the concept in very brief and discuss the question more apparently. That will be more helpful, more beneficial for you in at any way. So the next question say, for the double drainage in a clay layer of thickness 10 meter, the maximum drainage path is, so that is nothing but option number B, that is 10 by 2, because double drainage is there, so 10 by 2 is 5 meter. And this concept is there in the videos which we have, if you have discussed from the sir this class lectures, so on that only the questions are there, nothing is from us. And so in the consolidation, the parameter CV coefficient of consolidation depend upon the permeability and compressibility, only permeability, or the void ratio only. So option number A is correct, that is the permeability and compressibility. I have said many times, if only is what is there, it all naturally remove from the chances of being correct. Next question say, the settlement in the soft clay due to consolidations occur instantly over a long period depending on drainage, not at all or only due to the elastic rebound. So settlement in the soft clay due to consolidation occur not occur instantly, over a long period depending upon drainage, not at all due to elastic rebound. Option B is the correct answer, that it over a long period depending upon the drainage condition. Now, with this, we sum up the multiple choice question section. Now we will see some other questions and some numerical problems which we have kept over here for the more precise discussion of the topic. So first question is here, in which it is mentioned that a soft normally consolidated clay layer is 12-meter thick with the natural moisture content of 38%. The clay has a saturated unit weight of 16.8 kilonewton per meter cube with a specific gravity of 2.7. The liquid limit is 58% and the foundation creates the vertical stress of 15 kilonewton per meter square at the mid depth. Calculate the consolidation settlement if the groundwater table is at the ground level. This question is very much similar or more or less same like which we have discussed, in which we have calculated the consolidation settlement. If I remember, I 240. So over here, first of all, we have calculated the effective stress uh, per meter gamma dash as 6.99 kilonewton per meter cube. Then we have calculated depth of the mid layer comes out to be 6 meter. When we calculate stress at that point, that comes to be 41.94. And then delta sigma is also mentioned as 15, that sigma final comes out to be 56.94. Then we calculate E naught value, that is 1.026, give base on the basis of the specific gravity and the water content. Then on the basis of liquid limit, which is mentioned over here in the problem as 58%, we calculate the CC value, then we calculate the consolidation settlement, which comes out to be 340 mm or the 0.34 meter. So this is the very easy problem, but I just want to kept some more problem which we have discussed, or the similar problem, so that a better understanding could be developed. Now the next part of the problem say that a consolidation test on a saturated clay shows the void ratio of 1.15 and 1.08 at the effective stress of 100 kilonewton per meter square and 200 kilonewton per meter square respectively. Find the coefficient of volume compressibility MB for this stress. So first of all, we need to calculate AB. AB is nothing but 200 minus 100 divided by 1.15 minus 1.08. Once AB is calculated, we calculate MB as AB by 1 plus E naught. So AB by 1 plus E naught is 1.15. So over here you see, first of all, we calculate delta E, which comes out to be 0.07. Then we calculate delta P, which comes to be 100. Now MB equal to AB by 1 plus E naught. So AB is nothing but delta E by delta P. So delta E by delta P divided by 1 plus E1. When we solve it, this comes out to be 3.26 into 10 to the power minus 4 meter square per kilo newton. Now, next problem mentioned over here is say a clay layer 8 meter thick has a coefficient of volume compressibility MB as this. If the layer subjected to the pressure increase of 80 kilonewton, calculate total settlement. So if you remember, delta H value is nothing but MB into change in pressure delta sigma into H. So 0.00035 into 80 into 8 is equal to 0.224 meter or 224 is the answer for this problem. So this thing you need to understand. Now the next question is also more or less similar. So the numerical problem we are discussing over here, I will request one and all of you to go and solve these problems, at least these problems. Apart from that, I will suggest more problems from the standard books, so that will develop you better understanding of the concepts which we are going across. So moving to the next problem, you say a saturated clay sample has the moisture content of 42% and the specific gravity of 2.68. After consolidation, the void ratio reduces to 0.95. Calculate the initial void ratio and the volumetric strength. The initial void ratio is nothing but S equal to WG. From there we calculate E naught as 1.126. Next, say volumetric strain. So volumetric strain is E final minus E naught minus E final by 1 plus E naught. That comes out to be 8.3%. Now, in the next question, it is asked that a normally consolidated clay has the liquid limit of 75% and the plasticity index of 45%, estimate CC value using the Tajagi peak corrects correlation if the 10-meter thick layer get loaded from 60 to 120 kilonewton per meter square, find settlement. So the many problem is asking this. First of all, it said use Tajagi peak correction, so correlation. So if you remember, the compression index is given as 0.009 into liquid limit minus 10, so it is calculated and comes out to be 0.585. Apparently we assume E naught value as 1.2 typically for the clay, and SC value is calculated on the basis of that. That comes out to be 0.8 meter. Depending upon the assumptions of E naught, the different value could also be obtained. But in general, in the standard problems, those things has been mentioned. That is not the thing which you need to discover by yourself, right? Now you see the next problem in which it is asked that an over consolidated clay layer 6 meter thick has a pre-consolidated pressure of 180 kilonewton per meter square. Current effective stress is 100 kilonewton per meter square. CC value is 0.25, CR value is 0.05, E naught is 0.85, and stress increase from 200 kilo. Stress increases to 200 kilonewton per meter square. That is the Taylor sigma value is 20. So for this, we first of all calculate sigma naught is sigma p. So as recompression is CR into H by 1 plus E naught into log sigma p by sigma O. So from this, when we calculate, this comes out to be 41 mm. Subsequently, we see that the value, basically 1.8 by 1, basically pre-concentration pressure is 180 and current is 100, and now it become 200 by 180 because pre-consolidation pressure is 180. So from that we have calculated the recompression and the compression index. On the basis of compression index, those two settlements comes out to be 78 mm or 0.078 meters. So that is a very basic problem. I have said that I haven't kept, but apparently I have kept that question. But I will try to give some more problem, maybe without solution or with solution, depending upon your request or your timeline or requirement. If I see many people comes out for the lecture, I will try to do some hard work in that direction. Otherwise, this question may be sufficient. Okay, so a consolidated sample is 20 mm thick with a void ratio 1.1. After 400 kilonewton per meter square, void ratio dropped to 0.95. What is the final thickness? So again, HF equal to H naught into 1 plus EF by 1 plus E naught. So HF value comes out to be 3.57. This is not the problem of concern. And this is the simple problem. Next question said that a clay layer extend from 3 to 15 meter below the surface. Water table is at 2 meter. Gamma above the groundwater table is 18 kilonewton per meter cube, and gamma set below is 19.5 kilonewton per meter cube. To calculate the effective stress at 10 meter depth, so the total vertical stress first of all is 18 into 2 plus 19.5 into 10 minus 2, basically 10 meter depth. Above 2 meter there is no water table, so 18 into 2, and below it is gamma set is used, so that comes out to be 192 kilonewton per meter cube. Now when talk about pore water pressure, it lie up to depth of 8 meters, so 9.81 into 10 minus 2, that is comes out to be 78.48. When it comes about the effective stress, we subtract the pore water pressure from the total stress, that comes out to be 113.352 kilonewton per meter square. Next problem say that a 4 meter thick clay is in the double drainage conditions with the CB value equal to 2.5 into 10 to the power minus 3, calculate the time for the 50% or 90% consolidation. So these concept these concept mentioned over here is not discussed in this class at this point of time, but the concepts which he discussed by the sir at the NPTEL platform this concept has been discussed. That's why I have kept the problem related to the same, because my concern is to solve the problem, not the point of discussion which are going ahead. But for the better understanding, I briefly discuss the concept, but this concept is not there. So over here, if you remember those concepts, the drainage depth path is 2 meters, and the time factor for 50% is 0.197 or 0.196. So T50 equal to TB into CB, CV into D square. So 0.197 into 200 square by 2.5 into 10 to the power minus 3. That comes out to be this much minute. Subsequently, for the 19, that value is 0.848, and T90 comes out to be 13,000 minutes. You can convert it to day or maybe year. That's not the issue. And then that type of problem is also asked in the many of the examinations. Next question is related to the same, in which it is said that a clay layer of 12 meter thick, in which CC is 0.35, E naught is 0.125, and the initial effective stress varies from 50 kN per meter square to the 140 kN per meter square. Surcharge of 25 kN per meter square is also there. So find the settlement assuming the average stress. So average initial stress come to 50 plus 140 by 2, that is 95. And finally, 95 plus 25, because it is mentioned that surcharge of 25 is there. Then again we use the equation that is CC into H, that is 12 by 1 plus E naught, that is 1 plus 1.25 to log 120 by 95, and by solving that comes out to be 194 mm or 0.194 meter. Next question say that in a laboratory test, the 50% of the consolidations of a sample 20 meter thick single drainage occurs in 8.5 minutes. So determine the CV. So H is mentioned, 50% it is known, 0.197. So we have calculated the value of CV that comes out to be 0.927 centimeters per minute. Now the next problem say that in a consolidation test, initial thickness is 20 mm, the final after the expansion is 19.25 mm, the moisture content is 25%, GSC 2.65, while the diameter is 75 mm, the dry mass is 135.6 gram. So compute the void ratio at 19.25 mm, and at the 200 kN per meter square, thickness 9.3 mm. So everything is mentioned. Very simple problem. We could calculate the E value. That comes out to be 0.662 and 0.671. Now let's see that how much problem still left. So I think I could leave you. Okay, two problems only there. So next problem say two clay layers, each of 5 meter thick, CC is 0.32, E naught is 1.1, sigma naught is 60 kN per meter square, layer is normally concentrated, layer B over concentrated, sigma P equal to 100 kN per meter square, CR is 0.08, both get loaded to 150 kN per meter square. Calculate the settlement for each and compare. So first of all, for layer A, settlement is calculated on the basis of normally consolidated, and that comes out to be 0.607. For the layer B, the recompression settlement is calculated, and afterwards followed by margin compressions is also calculated, and that comes out to be 310 mm. When the difference between those two settlement is calculated, that comes to be 297 mm. Right. Now the next problem asked that a foundation applies a 30 kN per meter square over the two clay layers. The top 3 meter CC equal to 0.25, E naught equal to 0.95, and sigma naught equal to 40 kN per meter square. The bottom 4 meter CC equal to 0.18, E naught equal to 0.75, and sigma naught equal to 70 kN per meter square. So the find the total settlement. So again, this problem is related to the similar problem which we discussed in the previous slide. So solution is also mentioned over here. So I think you could easily manage these questions. So with this, we come up to end of the session. Thank you everyone for joining. We will see. I will see you in the next class. Till then, I will suggest you to solve at least these problems which we have discussed over here. Some more problems or concepts maybe I will share with you in the PDF format, which I will share on the Google Drive, and these videos are also there on the YouTube. So I will suggest that if you have missed this lecture and want to solve the problems, at least those problem section you could cover from here or maybe from the PDF, whatever feasible for you. Thank you everyone for joining. See you in the next class.